Hello and welcome. So in this session, let's jump into our first coding exercise with datasets, DataFrames, and Spark SQL. So the use case is that we have some employee data. The format is ID, name, age, and address. So basically, very small data set that contains ID of every employee, name of every employee, age of every employee, and let's say address, which contains the city. And the use case is we are gonna implement a Spark job, Spark SQL job, basically, which gives us all the employee which are greater than 50 years in age. Just a hypothetical use case to explain the concepts. So let's look at the code. So this is our code. I'll actually explain a few iterations of this code, a few variations of this code. So let's look at what exactly are we doing. When we are using Spark SQL, so instead of Spark context, first thing is that will be using Spark session. And this is the way you create a Spark session using a builder method of Spark session class. You provide your app name, you provide your cluster, and then you do get or create. So get or create is basically means that if a Spark session already exists, it can simply return you the same Spark session. If it does not exist, then it will create one for you. Then what we are doing here is we are reading the employee.csv file through Spark session, and we are converting it into a data set. So the format to do that is spark.read. Spark is your Spark session object. And then you provide an option where you say header is true, which means there is the first line in that CSV is the header line. And then you apply an option which says infer schema true, which means Spark should infer the schema from the header itself. So as we saw in our file, the first line says ID, name, age, and address. So what we are doing here is we are asking Spark to infer the schema from this header row. Okay. And then we are providing the path of that employee.csv file. This line dot as employee. If you see, this employee is actually a case class that we have defined in the first place. So this case class is nothing but format or schema of your data, right? Where you're saying your ID is int, your name is string, your age is int, your address is string, right? So when you supply a case class like this in your read method, it actually creates a data set out of this data, okay? It actually creates a data set out of this data. And what it is doing here is when you apply this method, it is basically statically, inferring, it is statically applying this schema provided by this case class to this data. Okay. And as we saw in our last lecture, in case of data sets, your schema is statically supplied. Okay. I'll explain what happens if you do not supply the schema statically. But for now, let's say you are supplying the schema statically through a case class and you are creating this data set, which is called employee data. Okay. Now, in the next step, what we are doing is we are simply printing the schema. All right. Employee data.print schema will print the schema. And then in the next step, what we are doing is we are applying a method filter on this data set. And the filter will take a where condition as argument. Okay. Just like you have a where condition in your SQL queries, it will take only the conditional part of that statement. And here you are saying that your dataset.age should be greater than 50. And when you supply this, what it will do is it will filter all the records from this employee.csv or from this employee data dataset where age column is greater than 50. Okay. And it will return it as a new dataset, and we are storing it in variable called seniors. All right. Now, after that, what I'm doing here is I'm doing seniors.collect. It's an action which will actually trigger the execution of this query. And then I'm simply printing all the results from the result variable. And then finally, when I'm done, I am saying spark.stop to stop the session. Okay. So let's first look at what happens when we run this program, and then we will see some variations of this code. Okay. So let me compile it using SPT package. All right. Let's submit the job. All right. So we got the result. So this thing is coming from employee data.print schema. So it is basically telling you what the schema of that data set is. It has an ID, which is integer. It has name, which is string. It has age, which is integer, and address, which is string. Okay. And finally, this is printing the result that we got after the filter query. And our filter query was to return all the employees where age is greater than 50. So you see these two results where age is greater than 50. Okay. So that's a very, very simple hello world type of example for data sets. Now let's go back to our code and see what are other options. First thing that I want to explain through this code is the difference between a data set and a data frame. Okay. Now, in case of data sets, we supply a static schema. Let's say I do not supply it. Okay. Let's say I do not supply the static schema with this spark.read call. And what happens in this case is if you just call spark.read up till this point, it's not really a data set. It's actually a data frame. Because the only difference between data frame and data set here is the static schema. If you don't supply the static schema, then your employee data is not a data set. It's actually a data frame. And when it's a data frame, you can still print the schema because it is going to infer the schema at runtime. Okay, it's going to infer the schema at runtime. So even a data frame has a schema. It's just that it's not available at the compile time. It's available at the runtime. And then the way to apply filter function on a data frame is not this. The way to apply a filter function on a data frame is this. So if it's a data frame, then your filter function, because it does not know about the schema at compile time, it's actually it takes as an argument as a where condition as part of, as a string. Okay, in the string you can provide your condition. Okay, which if true will result into the data being part of the result. If false, data will be dropped out. Okay, so in this case, now this is the way you apply your filter function on a data frame when it's not a data set. Okay, result will be same. You are still collecting the result from seniors, which is again a data frame, and then you are printing the result. So let's see what happens in this case. So you still will get the same result. Although this time we are doing the execution through a data frame and not a data set. All right, you still got the same result. Now let me go back to the code and explain what's the difference. Now you would ask, if you are getting the same result from a data set and a data frame, what's the need of supplying this schema, right? Why would you even supply this schema? Now think about a scenario where, let's say, you're using a data frame and you type a wrong query here. Let's say you say salary is greater than 50. Okay, what do you expect will happen? If I compile this code, do you think it'll give any errors? Not really, because the fact is the query that you have changed is actually a string. Okay, and data frame does not even know about the schema at compile time. So at compile time, whatever you write in that query, it will just accept it. So the compilation is successful, but what will happen if you try to run this job? If you try to run this job, it will actually give you a runtime exception because it does not know, I mean, the schema of that employee data frame does not really contain a column named salary, right? So what happened? You got an exception which says a column or function parameter with name salary cannot be resolved. Okay, because the schema only contains these 4 columns, right? So you got a runtime exception. At compile time, the data frame didn't even know that whether a salary column exists or not, right? Now let's go back to code again and do the same thing, with a data set. Now let's say I use a data set. So when I uncomment this as employee, it becomes a data set. And then in case of data set, this is my filter method. So let me comment this, and this becomes my filter method, right? And now if I, instead of age here, if I say salary, okay, what would happen? Let me try to compile it. So if I compile this now, it will actually give me a compile time error itself. Because in case of data sets, the schema is available at the compile time. It will know that the schema does not contain any column called salary. So it will give me an error at the compile time itself, which is much, much more efficient, right? So at the compile time itself, it told me that this column salary is not found in the schema. Better, right? And that is one of the big differences between data frames and data sets. Now let me go back to code once again. Okay. This is one way of, using data sets and data frames. There is another way. Okay. And that way actually provides you completely SQL-like interface. So in this case, you are applying this filter. I mean, internally, it's like a SQL query where you are, providing a where clause and providing a condition, but still it's not really a SQL statement itself, right? There is another way by which you can actually write exact SQL statement. So now let's say this is my data set, employee data, and the way to really use exact SQL command is this. Okay. I'm not applying this filter method anymore, neither on dataset nor on DataFrame. So what I'm doing here is, now my employee data is a dataset. I'm applying this method called create or replace temp view. Okay. Temp view is basically something which makes your dataset or your data frame exactly like a relational database table. Okay. What I'm doing here is I am actually creating a view which is like a table in a relational database, and I'm naming that table as employee. Okay, you could name it whatever you want. And when you say create or replace, it means that if a view already exists on this data set or data frame, then it will return you the same view. If a view does not exist, then it will create one for you. Okay, but eventually you will get a view, okay, named employee on that data set or data frame. It doesn't matter at this stage whether it's a data set or data frame. This method is available for both data sets as well as data frames. Okay, so after this statement, you actually have a view called employee, which is like a relational database table. And on top of that table, you can actually run any SQL query you want. And in the next step, if you see, what I'm doing is I'm using the Spark session object that we created here, right? I'm using that Spark session object, and I'm using a SQL method on that Spark session object. And in that method, what I'm providing as an argument is a SQL query. I'm sure most of you are familiar with this. So I'm doing select star from employee. So this is the name of the view, right? Which we created here. So I'm doing select star from employee where age is greater than 50. Now your SQL query could be anything here. If you want to compute average age, you can do that. If you want to filter on something else, you can do that. If you want to filter on city, you can do that. I mean, it's as similar to a SQL query as it gets. It's actually not just similar, it is the SQL query, right? And after you do this, again, you get your result from the seniors, because seniors is again a data set or a data frame, depending on what was your employee view created on. Okay. So now if you do this, you will still get the same result. It's just another way of coding. So if you like to write perfect SQL queries, then this is the way you would be using Spark SQL. Okay. Right. Let's run it. And you would get the same results. So we just looked at three different ways of getting the same results: through a dataset, through a dataset filter function, through a dataset create or replace temp view function, and then using Spark SQL through a DataFrame filter function. Okay, and we know the difference. A dataset basically gets the schema at the compile time, and it hence can detect errors in your SQL statements or in your filter functional kind of functions at the compile time itself. Whereas a data frame does not have schema at the compile time. It gets the schema at the runtime, and then it can detect errors related to the schema only at the runtime. Okay. Internally, the execution is happening exactly the same way in all three cases. Internally, it gets converted into a logical query plan and then optimized query plan. And then that query plan is actually executed using RDDs, which is the lower level Spark APIs. So this was our very first hands-on exercise with datasets, DataFrames, and Spark SQL. This was more like a hello world example. We'll dig deeper into more hands-on exercises with the Spark SQL datasets and DataFrames in our upcoming sessions. Thank you very much.